Welcome to Point to Point channel. So I'm going to discuss about Spring Data JPA derived queries. So I'm going to cover these below points. What exactly derived queries and um so derived queries versus the explicit queries using at the rate query annotation. What's the difference? Okay, and so what type of queries we can fire using these derived queries? Okay, and when exactly we need to go for these derived queries and when we need to go for external queries using at the rate query. Yeah, so without wasting time, let's jump into the coding part. Yeah, so just sometime before I have created one demo project to demonstrate the particular video. Okay, so here if you see, uh, yeah, I have two entities here. If you see, author entity and this is a book entity. So just to demonstrate this particular video, I have taken these two entities. So basically, one author can write many books, right? So here I have at the rate many to many. Here you see at the rate many to many unidirectional association between author and books. Okay. So here this is not required. I'm just deleting this. Okay. Yeah. So here if you see cascade is equal to cascade dot persist, hardly we have some four fields. Author has ID, name, age, and active and date of birth. Okay, and obviously one author can write many books, so obviously list of book, right? So now if you jump into book, okay, here if you see book has ID, name, and book price. So here I didn't have at the rate many to many association even from book to author. Okay, I just maintained unidirectional association from author to book. Okay. So this is just a example association between author and books. Okay, so these two are just respect to repositories. Okay, here you can see author repository. I have few methods. Shortly, I will discuss all those methods. Okay, so here if you see, this is book repository in which I don't have any methods. Okay, I'm going to demonstrate with respect to author. Okay, so here if you see, this is a utility package in which I have written some lazy testing. Okay, so just to overcome lazy initialization exception, I have written one separate class. That's it. I will explain after a while. Okay. So here, if you see, this is just a main class in which we have a main method, nothing fancy. Okay. So this is a resources application dot properties. Here I just maintained the data source related properties to interact with MySQL database. Okay. So this is just a test case. Okay. So here if you see this test case, just to demonstrate all the different scenarios of derived queries, I have written one test case. So this is a high level code walkthrough. Okay. So now, now let's jump into the main objective of derived queries concept, right? So here in our real day-to-day life, okay, so we will interact with the database to fetch a data from the database, right? So obviously we need to write some select queries, right? So so we need to write with some at the rate query annotation. Inside that we will either write jpql or native queries, right? So Spring Data JPA team thought, okay, why don't we derive the query based on the name of the method which is defined in the repository? So can't we do like that? So just a thought came from that team. Okay, so so they just implemented accordingly. Okay, so whatever the method name we write, if it sticks to their standards or their predefined what do you say expressions or keywords, then I mean then you no need to write any query with at the rate query annotation. Internally, Spring Data JPA will derive the query based on the method name what you define in your repository. So that's the beauty of derived queries. Okay, so here 90% of the scenarios of all select queries in which usually if you think in the select queries, what and all we can have, see for example in the where clause select something blah 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 some so and so column names from so and so table, where so and so column is equal to so and so value, right? So or where column is equal to so and so value, column 1 is equal to so and so value, and column 2 is equal to so and so value, right? Or otherwise or operation also, right? Or for example maximum you can have, for example, what you say, where column 1 is null, column 1 is not null, or where date of birth is greater than so and so date. So just example sake I'm saying. So like this we have n number of requirements in our day-to-day life, right? So all those requirements we can fulfill with the help of these derived queries, right? So even once you get the results, I mean, even you can sort the results in either ascending order or descending order also, right? And even in your parent entity, obviously here if you see you are pointing to books entity, right? So even we can uh, here if you see book entity where it is, yeah. So, for example, not only these straight columns within the author, even we have association with the book right here. So, even within the book also we have few columns. So, even we can derive the query based on the attributes specified in the book also from author repository. Even that also can be that is also can be possible. So, like that, most of the scenarios we can fulfill with the derived queries. In case if derived queries are not able to fulfill your requirement, then you can think about writing either JPQL or native query with @query annotation, right? So yeah, so this is the background between derived queries versus explicit query. Okay, uh, so now if you see here, um, okay, yeah, just to demonstrate, first of all, we need to insert few records, right? So here, if you see, for demonstration purpose, I mean, I have created five books. What do you say? Five book records. Okay, here four author records. Okay, so obviously here, if you see, so I just tied these books with each other. So, for example, here, if you see, author one has written four books: book one, book two, book three, book four. Okay, author two has written three books: book three, book four, book five, or something like that. Here you can see. So accordingly, I have tied a list of books to each author, right? So obviously, finally, I'm saving. Okay, so now let me run this. Okay, uh, so here, yeah, it will take a while. Meanwhile, I will show the data is my database. I'm just refreshing. Okay, so here, if you see, I'm just refreshing. Obviously, nothing is there. So shortly, it will create three tables. Why three tables? In the many to many association, you know. So it will create one more joint table, right? Author underscore books and author and book, right? So author consists of a list of author records, book consists of a list of book records, and author underscore book consists of association related records in the author underscore book. I mean, so this author is associated to this book or something like that. Okay, so once the records are inserted, then we can fire few queries based on the method names, right? So here if you see, so it has created few tables. Okay. Yeah, so this case is pass. So I'm just refreshing the DB. Yeah, as I said, here you can see author books and book, right? So first of all, author, I'm just refreshing. Yeah, here you can see four authors. Okay, here first author name is Rajendra, Ajay, Rajendra, okay, and Ravi, right? So their date of birth and accordingly their age, okay, and active, whether they are currently active or not. That's it. Okay, and if you see the book, okay, obviously I have five books. So book one to book three, book name and book price. That's it. So author underscore book means obviously what you say their association. So here if you see, first author has written four books, right? So one here you can see one two three four. So accordingly, all four authors related entries. So so far so good. So now first derived query. Here if you see simple one. Okay, for example, what do you say, if you want to fire a query or if you want to derive a query based on what do you say, based on name attribute, in the sense you want to fetch authors records whose name is Rajendra, for example. Okay, so usually what you do, I mean, you will write some query annotation. Okay, select a star from author where author dot name is equal to Rajendra or something like that. You will write, right? So here no need to write anything. Okay, here we need to define these type of methods in the repository. Okay, so here the standards are something like this. we need to write find by. Okay, so find by. Okay, this is important. Find by. Okay, after that, whatever the column you are interested, you want to pass the input, so that you need to specify. So now, for example, here if you see, okay, I want to fetch authors list based on the author name. So then find by capital N name. Okay, so you want to fetch authors by their age. For example, find by age. A is a capital. We need to write like that. Okay, so if you want to fire a query, find by date of birth, find by date of birth D capital, find by D O B, something like that. Just you need to pass the respective field name, so internally it will fire the query. So very simple. Okay, so here if you see, yeah, so yeah, find by name, right? So what I'm doing, simply find by name. So if you go here, this is author repository. Here we need to write like this, just find by name, string of name, list of others, that's it, right? So now, um, so this find by name, obviously it will fire a query, right? So I will show the query also here. If you see, yeah. So after that, what I'm doing, I'm just printing only their author names, that's it. I'm not doing anything fancy. So if I get two authors, means it will print two authors related names, right? So okay, for I will fire what is it? I will run this one. So however, meanwhile I will show you. It will. I just commented this particular query. Okay. So here, if you see, it will fire like this. Okay. So select something something. Okay. So here, if you see from author. Okay. So where author underscore name is equal to question mark. So this question mark value I'm just passing as a Rajendra, right? So so obviously it will fetch all the authors list whose name is Rajendra. So here, if you see, it will print two authors. Obviously, I'm printing only names, right? Other names. Obviously, it will print Rajendra. So here you can see I'm just mapping only author's name, right? So in the database also, if you see, we have two authors with the name Rajendra, right? So Rajendra and Rajendra. Right? So now, see, it has already fired. So yeah. So here you can see we didn't write any query with @ query annotation. We have written only method name. Okay, so internally it has fired a query happily. So here you can see. So this is the query, simple query from author. Okay, where author dot name is equal to question mark. That's it. This is the output. That's it. So now, okay. So this is just example sake. Like this. You can. You can. Write for any other attributes of that particular author entity. Even you can write find by age, find by date of birth, find by active, find by name, or whatever, blah blah blah. So now, uh, see, find by name is equal to, they have also given a few more options. So we can also write a query by name also. We can also write read by name also. We can also write get by name also. So here you can see the same stuff with a different method name. Here you can see same thing, get by name. Okay, it will also fire the same query, same thing, same query, same output. Here you can see we can also write with the read by name also, same thing, same query, same output. Here you can see we can also write using query by name, but usually 99% of the cases, we are habituated to write with find by only. So mostly we write with find by only. However, still we have a provision to write even in other ways also, like get by name, read by name, query by name, or something like that, right? So yeah, so this is one thing. Okay, and after that, even we can count the number of authors based on some conditions. So for example, count by name. So I want to find out the count whose name is Rajendra, right? So obviously I will get count as two, right? So there are two others, right? So obviously it will, just to save that, minimize the time. I'm not running this each and every test case. Why? Because it will take a while, right? So just to reduce the, just to save the video time, I'm explaining you this particular query, right? So here if you see, it will fire query like this. Okay, select something from author. Okay. Uh, Sorry, here you can see select count of author underscore ID. This is important. Okay. From other, where other name is equal to something, out is equal to, right? So that's it. Very simple. So now here if you see, yeah, as I said, I mean, if you want to fetch the list of others based on their age, find by age. That's it. Here you can see find by age, and just we need to pass the age. So now it will fetch the authors whose age is 32. That's it. Okay, just we need to write like this: find by age in the repository, right? So that's it. Okay. So obviously it will fire like this. Okay. Um, yeah. So there is only one single author whose name is Ajay. The age 32, right? Yeah. So after that, if you see. Um, multiple conditional expressions in the sense uh, okay, so I have also prepared this one. Okay, what to say, PowerPoint presentation. So yeah, whatever we discussed so far, okay, let me parallelly show you this PowerPoint also. Okay, so here if you see, this is what we have seen so far. Okay, so these derived queries are mainly for select operations and deletion operations. So here you can see they are like this. We can do find by this yellow color highlighted part is the entity attribute. Here you can say name or age or date of birth or whatever, right? So yeah, find by name is equivalent to query by name, read by name, get by name. All four are equal, same. Okay. So here if you see, um, yeah. So similarly find by age, right? So after that. even even we can write like this also, find by age. We can also write the method name as find by age is. Okay, and we can also write the same method with find by age equals. All three are same. It will say, I mean, it will fire a same query with same output. So I mean, it's our wish how we can what do you say, choose a method name. Basically, I want to say all these three methods represents the same thing. Okay. So on contrary, if you want to fetch the list of others whose name is not matching with the input what you are passing, then you need to write like this: find by age not, or find by age is not, or something like that. Okay. So basically this is this one. Okay. And here if you see, okay, of course, I mean, um, yeah, so multiple conditional expressions. Okay, one second. So I think before reaching here, yeah. So yeah, we will come back to multiple conditional expressions. So I want to cover few more equality related conditional expression. Here you can see find by active true. So find by active true in the sense, see in the author we have a Boolean field, right? So with the name active. So if you want to fetch all list of authors whose status, I mean, whose active status is true or one. Okay, so then we just need to write like this. Okay, find by active true. That's it. Find by active true. You no need to pass like anything here. Why? Because you already specified true, right? So it will fetch, it will fire like this. So here you can see from author where author active is equal to one, right? Here we are not passing any input parameter. Why? Because since you are not passing anything, you just specified find by active true. Obviously it has considered one. So these are the list of others whose active status is one. So suppose on reverse. So if you want to fetch the list of us whose active is false, in the sense find by active false. That's it. Very simple. Okay. So after that, here if you see, yeah. So if you want to fetch the list of others whose name is null, for example, okay. So you need to write like this: find by name is null. Okay. Uh, Similarly, find by name is not null or something like that. So here you can see we don't have any authors whose name is null, right? So obviously here output nothing, nothing it will print. So it will fire a query like this. Okay, from author where author name is null. So this is important, is null. So since in your method you have specified find by name is null, okay, in the query also you can focus here is null. Okay, it has appended with is null, right? So okay, yeah. So now here if you see, so yeah, so these are the equality conditions whatever I discussed just now. So find by active true, find by active false. Here you can see Spring Data JPA files you query to fetch the others list whose field active is true, similarly false, and similarly find by name is null, name is not null. Okay, so it will fetch the list of others whose name is null or whose name is not null. So till now we have covered equality condition related keywords. Okay. So now if you see this multiple condition like expressions in the sense, okay. So here, I mean, you can pass multiple input parameters, right? So with the help of and or, okay, here you can see, okay, now I will go back here a bit upward. Okay, so here if you see, uh, yeah, so this is the one. Yeah. So for example, I want to fire a query, find by name and age. So in the sense I am passing name and as well as age. So my intention is to fetch a list of others whose name is Rajendra and age is 42, right? If these two parameters matches with any one of the record, obviously it will fetch those type of records, right? So here if you see, the main part here is, okay, I have written find by name and age, right? So here if you see from author dot name is equal to question mark. Here this is important. This and author dot age is what something. Obviously output is in Rajendra, right? So same thing with or operator. Find by name or age. Okay. So now it will fetch a list of others whose name is Rajendra or whose age is 42. Okay, it can fetch either one of the thing. Okay, so obviously here you can see. So this is important. This is R. So here you can see R. Okay, so obviously we have got two records this time. Okay. So this is about multiple conditional expressions. So here you can see the same thing I just documented here. Okay, usage of and or keywords. Okay, so accordingly it will fire a query. Okay, if you specify and in the sense it will add and operator in the query. Otherwise or. Okay, the same thing I specified. Okay, so here if you see, uh, I think after that, yeah, we will discuss this similarity condition keywords. So again, I'm just scrolling down. Okay. Um, yeah, sorry. Before that, I want to cover one more scenario. So here you can see find by name is not in. So find by name is not in the sense. Okay. So we have discussed it till this part, right? I mean, I have said like if you want to find out list of others whose name is not matching with the input parameter, obviously find by name is not, right? That's what I said, right? So is not, here I just added one more thing, is not in. Is not in the sense, okay, I want to pass some list of authors names. Now I want to fetch a list of authors, okay, whose names should not match with the should not match with the these input parameters whatever I'm passing, right? So that's the intention, right? Usually in normal select queries, what you do, I mean, you will pass I mean a list of other names in the using in operator, right? So then accordingly it will fetch the results, right? So here you can see, so the same thing, I'm just passing arrays dot as list. So of Rajendra and Ajay, obviously it will fetch all the remaining list of others whose names doesn't match with these two names, right? So here if you see, this is important. Okay, from author. So here you can see where author underscore name not in. Okay, so obviously these two question marks represents these two input parameters, Rajendra and Ajay, right? So see how it is firing derived queries based on the method name. Okay. So obviously it will return one single author name, that is Ravi, right? So this is what I want to say. Now this one we have already discussed. Active true is null. This one we already discussed. Yeah. Now this is one starting with in the sense. So I mean, so this is one more set of different derived queries. Okay, here you can see I mean these category known as similarity condition keywords. So for example, I want to fetch a list of others whose names are starting with some ra or a ra, or whose names are ending with ra. Okay, for example, or whose names containing a simple what you say, a simple word or simple letter, you can say aj. Okay, or for example, I want to write some custom expression. For example, like here you can see, okay, first two letters what you say could be anything, and third letter should be a and followed by remaining letters, any that could be anything. So suppose if I have this kind of requirement also, then I can use like or something like that, right? So here that's what I'm saying. Here you can see find by name starting with. Okay, so obviously find by name till here we are familiar, right? Find by name, now we are just appending starting with. So which represents, I mean, the whatever input you are passing, obviously it will match authors names with this passed input, right? Here you can see author name, where author name like operator, internally it will use the like operator, and accordingly it will pass that input whatever I'm passing, and it will give the output. Okay. Okay, here you can see the same thing ending with. Okay, here also you can see find by name ending with vi. Vi in the sense obviously it will give the result as Ravi, right? So here you can see the same thing. There are the name like Ravi. Similarly, one more thing, containing. Containing also, I mean, so I want to fetch the all list of others whose name consists of these two letters AJ. So obviously my intention is Rajendra also has AJ. Okay, and Ajay also having AJ, right? So obviously it will fetch Rajendra and Ajay, right? So here you can see what it is firing. This is important. With the help of like operator, right? So yeah. So this is what the similarity condition keywords. Okay. So now let's discuss about this comparison condition keywords. So this is one more category in the case of derived queries. So for example, we have a requirement something like this. Okay, I want to fetch all list of fathers whose age is less than 40 years or whose age is less than or equal to 40 years, right? And similarly, similarly, I mean reverse also, whose age is greater than 40 years or greater than or equal to 40 years, all right? And whose age is between 30 and 40 years, and whose age is in operator, in operator. And sometime before I have shown you not in operator, so this is in operator. Find by age in. Okay, I will just pass some list of ages. For example, 30 and 40 I'm passing. So if it matches, if the records are available, accordingly it will pull the records. Okay, now if you see find by DOB after. What does it mean? I want to fetch the list of others whose date of birth uh, is after the past input date. So for example, what I'm passing, I mean 1985 January 1st, right? So now it will fetch all list of others who born after 1985 January 1st. So this is nothing but a comparison condition keywords. Now I will show you in the database. I mean, what is it? The test cases. So you can see find by age less than. So here you can see find by age less than. That's it. I'm just passing 40 years. We just need to define like this in the repository. That's it. And obviously that return type is list of others int age. That's it. Okay. So um, here if you see this is the query is important. Here you can see where author underscore is less than question mark. So it will fire internally like this query. Why? Because you have written less than, so obviously it has considered less than. Here you can see. So similarly here you can see less than equal to. Now this time less than equal. Okay. So here I just pass 36, right? So now it will fetch a list of either authors whose age is 36 and even below 36, right? So here you can see this is important. Less than or equal to. This line is important. Author is less than or equal to question mark, right? So accordingly it will fetch the list of other names. Okay. So now if you see find by age between, so this is important. Find by age, till now we are familiar. Find by age. Now these are additional keywords: between, find by age in. Okay, find by age less than, greater than equal. These are additional keywords. Okay, as per our requirement, we just need to define the derived query. So you can see find by age between. I'm just passing 30 and 40. So obviously it will. Here you can see. So this is important. Where are the queries between so and so value, question mark and question mark. So now it will print the author's names accordingly, right? So this is the last what to say last derived query method under this category, comparison condition keywords. Here you can see find by age in. Okay, so here if you see I'm just passing find by age in, I'm just passing listed out of 32 and 36. So in case if records are available with the authors whose age is 32 and 36, it will fetch. So here you can see yeah, there are is in. Here you can see this is in. Okay, and it's just considering two input parameters. So obviously it has written these two authors, Ajay and Rajendra. Okay, so this is nothing but this comparison condition keywords category. Okay, and yeah, I think this one we have already discussed. Find by date of birth after also. I think oh yeah, so this is sorry, this is also comes under the same category. Here you can see find by DOB after. Yeah, I'm just passing this input parameter local date at person 1985 January 1st. So here you can see how it is firing query. So yeah, where okay, author underscore date of birth, okay, greater than, okay, here you can see greater than question mark. So that is what I mean. Here you can see after data DVB after. So similarly you can write DOB before also. Then I mean internally it will fire a query with less than okay. operator. So accordingly, it will give the output. So now with this, I mean, we have covered all these comparison related condition keywords also. So A is less than equal to, greater than equal to, A is between, A is in, or DOB after, or whatever. All these uh, type of derived queries comes under comparison condition keywords. Okay. So after that, okay, so this is the next category. Here you can see this also we already covered. Similarity condition keywords they already covered. Okay, so here if you see sorting the results with order by. Okay, so somehow we have written some derived queries. Okay, it has started returning the results also. We are happy, but now we want to sort the results. Okay, for example, I want to sort the results based on some specific field name. Okay, either in ascending order, descending order. So then we need to write like this. So for example, find by DOB after, just now we have seen, right? Okay, find by DOB after, so just now we have seen. Okay, so for example, this is the derived query. Okay, we have got some list of others, we are happy. Okay, now I want to start sorting the results of this outcome. Okay, what I want to sort based order by name, descending order. So we need to write like this: order by name, descending order. So name in the sense, so here in the C author we have many fields: ID, name, age, date of birth, active. So I can choose any other field. So based on the field whatever I specify after order by, so then accordingly it will try to sort either in ascending order or descending order. So since here I am interested in the descending order by name, descending order. So then here if you see, I mean, so we need to pass here. You can see, yeah, come down. Yeah, so here you can see find by a date of birth after order by name, descending order, local data pass. So right, so obviously I'm trying to fetch all list of others who born after 1985 January 1st, right? So here, yeah, find my name, descending order. So here if you see the output here, Ajay, Rajendra, Ravi, right? Now I want to fetch the list of others whose name in the descending order. So what it will take here, if you see, reverse. Reverse in the sense Ravi, Rajendra, and Ajay, right? Obviously, the descending order in the sense, right? So this is what you say. Uh, this is how we can sort the results, right? And for example, if you are interested in ascending order, order by name, ASC. That's it. Okay, so there is I mean, there is one more other alternative way. So I mean, like this also we can sort the results. I mean, this is a bit additional code we need to write. Okay, for example, you no need to write order by name, descending order. We need to write simply like this: find by DOB after only. So there we need to pass one more additional input parameter, that is sort. Here you can see new sort of sort dot direction dot descending order. So this is the field name. So here I am interested name, right? Order by name. So like this also we can do sorting. But if at all I mean, you want to use only derived queries in the sense, you can choose the first approach. Okay, so simply by writing I mean method name, I mean internally it will fulfill your requirement. You no need to pass one more parameter like this. Okay, so this is what sorting the things. Okay, so after that, yeah, limiting the records. So limiting the records in the sense, okay, sorting we have covered, right? So sorting we have covered. Yeah, now limit the results. Okay, so now, okay, we are able to fetch the results happily, and after that even we are able to sort the results also. I mean, so till now we have achieved all these things. Now I don't want all the results. So I don't want to return all the records. So for example, if it returns 12 records, I am interested to see only first two records. So for example, if I have such kind of requirement, okay, even we can what do you say? We can specify the same thing even in the method name by something like this. Okay, so find top two. Okay, top two. Okay, by date of birth, by DOB after order by name, descending order. This and all is same. This and all is I mean already we have in the previous what is say the previous slide. So here you can see in the previous slide what we have: find by DOB after order by name, descending order. Right now, just in between find and by, I am just appending a keyword like top two. Either you can write first two also, first two or top two, both are same. Okay, so then what it returns, I mean it will return only two records, right? So here you can see, and yeah, yeah, that's what I have written: find top two or find first two, both are same here. Okay, so here you can see, yeah, in the code, the same thing, find top to, okay, DOB after something something blah blah blah, I'm just passing 1985 January 1st, right? So now it will fire a query. Here you can see from author, author date of birth, okay, order by, okay, we have interest order by author name, okay, single order, yes, this is fine. Okay, so where is limit operator since, yeah, here, yeah, so limit, yeah, from author, where order by, top to, one second. Yeah, see, this is the limit operator. Sorry, I didn't see this one. Here, you see limit. So if you specify top two or first two in the method name, obviously it will use the limit keyword, okay, within the query, and accordingly it will return only two records. Here you can see in the previous query we have three records, right? Three names, Ravi, Rajendra, and Ajay, right? Since I have specified top two, now it has printed only two names, right? So this is what limiting the results. Okay. So now, now we'll see one more category. Okay. So yeah, so if I want to fetch the parent entity records based on the child entity field value. So till now we just played with the entity attributes of straight away from author entity only, like name, date of birth, active, or whatever, blah blah blah. Now, okay, I want to derive the query based on the book's name. So here if you see in author, okay, for example, if you see author, so these are the straight fields in the sense right columns within the author table, id, name, date of birth, active, date of till here. So now this is just a association. We have many to many unidirectional association with the book table, right? So now, of course, we have this books, what do you say, books variable also. Now if you see in the book we have three fields. Now, is it possible to derive a query in the author repository based on book ID, or based on book name, or based on book price, or whatever? Is it possible? Yeah, it's possible. Okay, so here if you see, uh, yeah, so here, yeah. So for example, find by book's name. Okay, find by book's name in the sense. Okay, so here if you see, okay, so this is books. So like for example, if you have A's in the sense, what we are doing, find by A's, A is capital, that's what we are using, right, in the method name. Similarly, books, B is small, so obviously I will write books, so books, what you say, uh, here, B capital. Here you can see find by books, right, B capital, and after that within the book I'm interested in name. So right, so what does it mean? So for example, if I pass Java 8, so I want to fetch all list of others who wrote a book with the name Java 8. So that is my intention. So here if you see, even that is also possible. So that's the beauty of derived queries. Okay, right. So here if you see, internally it will fire a query like this, something like this. So here if you see from author, left outer join, so obviously we have three tables, right? Yeah. So author underscore books. Here you can see in author underscore books, we have this association, right? So here, I mean, by looking at this particular table, is happily we can fetch all list of others who wrote the so and so book, right? So that's why author underscore book. Okay. So and after that, I mean, this is just a trial condition. Okay, and again left out of trial and so and so book. Okay, so here you can see finally where book name is equal so and so. So, right. So this is the list of others. So now Rajendra, Ajay, and Rajendra. I mean, so they have written a book whose name is Javite. So see how simple these derived queries are. So yeah, and after that, yeah. So for example, okay, I want to fetch a list of only author names. Okay, I don't want to fetch list of authors. I want to fetch list of author names. Okay, I mean, whose others status is true. I mean whose others are active currently. For example, okay. So for example, if you see this, okay. So here you can see find by distinct name, okay, by active or something like that I have written. So here you can see this one I cannot fulfill with the derived queries concept. So obviously I have taken the help of @query annotation. Here you can see @query. So what I have written, select a distinct a dot name from author, okay, where a dot active is a question mark one. So I'm just passing true, right? So one I'm passing, so obviously it will pass one, and straight away it will return the results of author names, right? So since I am not able to fulfill this particular requirement with the derived query, so now I have taken the help of @ query. So that's the difference between a derived query versus an explicit query, right? So here if you see, yeah, so when you are writing explicit query, you no need to follow derived queries exact method naming convention. You can write any name. Okay, when you are taking the help of @ query. Okay, see here I'm just passing true. So obviously, okay, it will file the same query what you wrote in the @ query annotation, right? So this is what we have written right in the @ query annotation, right? So this is what @query. Okay. So and after that, okay, in the initial slide, I also told like these derived queries are helpful for select operations and as well as delete operations, right? So for example, I want to delete all the author's records by their age. For example, delete by age, like how, like if you want to fetch, then find by age, right? If you want to delete, delete by age. So of course, in a JPA repository, we have predefined methods: delete by ID or delete all by ID. Okay, so there you need to pass the primary key. So then accordingly, it will delete the list of others. Now, no, I don't want to pass the primary key. I want to pass the other attributes of that particular entity. For example, like this age. Okay, so now I want to delete the author's records by their age. Is it possible? Even that is also possible with the derived queries. Here you can see delete by age of 28. Okay, so my intention is I want to delete all the authors whose age is 28. So here if you see, it will fire a query something like this from author. Okay, so where author age is equal to so and so. Okay, yeah. So see here it will fire three queries. Okay, so this is query one for select operation. Okay, so it will first fetch a list of authors whose age is 28, and after that it will fire another query, query two. Here you can see. So this is query two. So here you can see happily it will fire one more query to delete from author and school books. Okay, whose author ID is equal to something something. So that means in the first query it has find out the author IDs whose age is 28. Now it's just passing that author ID as an input to the second query. Here you can see where author ID is equal to something, I mean question mark. So it will just delete the record from the author underscore books. Why? Because earlier I said, right, so this is a joining table in which we have a association between the author and book, right? Here you can see now it should break this association, it should delete this association from this particular table. Okay, and finally it will find a last query, that is delete from author. Okay, delete from author where author you can, where ID is equal to so and so. So right, see, you have written only the simple method delete by AZ and you are passing. So internally how it how it is intelligent to fire all these three queries. So that's the beauty of derived queries, right? So uh, so here if you see, okay, delete all by name. So just now I said, I mean, we have a predefined method delete all by ID, right? Now I want to fulfill something like this with the help of name, delete all by name. So here you can see delete all by name, I'm just passing Rajendra, okay, for example. So then you see, um, so this time, this time also it will fire one select query. Okay, so where author name is got so and so. Then obviously it will fire a delete query to break the association from the author and books. Okay, so this time what happened? I mean, it will find two records whose name is Rajendra. So obviously two others are right there, right? To, I mean, with the name Rajendra. So obviously, what you say, query two and query three. So this is for two authors, author one and author two. First Rajendra and second Rajendra. And similarly, fourth query and fifth query are also, I mean, to delete author record, what you say, for first Rajendra and second Rajendra, right? See, it has fired five queries accordingly. So, I mean, that's the beauty of SpringDataJPA derived queries. So, yeah, we have covered almost all the scenarios, okay, uh, of SpringDataJPA derived queries. So, here you can see, uh, yeah, so this also we covered. Yeah, so delete records. Yeah, this is what I mean, we just explained. So, I mean, till now. So here you can see CRUD repository has predefined methods to delete the records by ID. Okay, so something like this, delete by ID or delete all by ID. Now, I mean, we can delete the records using derived queries, something like below. Okay, so find delete by age or delete all by name or something like this, right? So yeah, we have covered almost all the scenarios of Spring Data JPA derived queries concept. So overall, I mean, in 90% of the cases, I mean, we can happily make use of the derived queries. Still, if it doesn't fulfill your requirement, then you can think about writing explicit JPQL or native query using @ query annotation. So yeah, this is what derived queries concept. Yeah. If you yeah, if you really like my video, just like it and share my video and subscribe to my channel. Thank you.